So one of the university question asked is draw the circuit of instrumentation amplifier and explain its working. Okay, so basically you know that what is meant by an instrumentation amplifier. It is an amplifier circuit which is used to amplify the signals, and mostly it is used in industries where we have to amplify the output signal from the transducer. Okay, so what is asked in the question, you have to draw the circuit diagram and explain its working. Okay, so you know that the instrumentation amplifier mainly consists of two stages. Okay, so what are the two stages? The first stage is called as your differential input output amplifier, and the second stage will be your difference amplifier. Okay, difference amplifier. Okay, difference amplifier. So first let us draw your first stage, that is your differential input output amplifier. So basically your differential input output amplifier is a combination of two non-inverting amplifiers. So what is your non-inverting amplifier? If the input is applied across the non-inverting terminal, then it is called as a non-inverting amplifier. So you have a non-inverting terminal and an inverting terminal. Okay, and let me give the supply. Okay, and you have the basic non-inverting amplifier. So let me take it as R1 and R2. Okay, so this is this amplifier, let me take it as A1. So now your A1 is acting as a non-inverting amplifier, isn't it? Now we are going to draw another amplifier which is also a non-inverting, but it is just ulta you have to draw, that is non-inverting terminal to the down and your inverting terminal. Here also I am going to apply the input, another input V2 across your non-inverting terminal, and now I am going to configure, I am going to use the same resistor R2 as the ground. Okay, so let me remove the ground here. So the resistor R2. Okay, now I am using one more resistor. Let me take this as R3 and I am just joining it. Now let me take this node as A, B and C. So you imagine that you, for a time being, you imagine that the node B is now grounded. So if node B is grounded, you are not using A1. So what will happen now, A2 along with R3 and R2 will act as your second non-inverting amplifier. Okay, so this will be your plus VCC and minus VE. Okay, so you have a combination of two non-inverting amplifiers, that is amplifier A1 and amplifier A2. Individually these two are acting as a non-inverting amplifier, and your resistor R2 is taken as your variable resistor by which you can control the gain. Okay, so now the output of the two resistors, that is your output of the two op amps A1 and A2, will be fed as your input to your difference amplifier. So now I can partition this into your stage 1. So this will become your stage 1, that is your differential input output amplifier. Now you have to draw your difference amplifier. So what will be your basic difference amplifier? Inverting terminal, non-inverting terminal. Across the inverting terminal you have your resistor, right? And across the non-inverting terminal your compensation register. So R3, now I can name it as R4, R5, R6, and I am taking R7 as your adjustable resistor here, and the overall output is taken as V0 and your load resistor RL. Okay, so here you have two resistors, that is R2 and R7 as variable resistors. So what is the purpose of your R2? R2 is used to control the overall gain, to adjust the gain. Okay, R2 is used, and R7 is used as common mode nulling, common mode rejection. It is used for common mode nulling or attenuating the noise. Okay, so these are the two purposes of your resistor R2 and R7. Now here also let me give VCC and minus VE. So this makes your second stage, that is your stage 2, which is your difference amplifier. Okay, so it's a combination of two stages. First stage is differential input output amplifier and stage 2 is your difference amplifier. Now what will be your overall gain? Overall gain ACL. So ACL is nothing but your closed loop gain is equal to ACL1 into ACL2. So what is your ACL1? That is your closed loop gain of your stage 1. And what is your ACL2? Your closed loop gain of your stage 2. Okay. So now let us find out the gain ACL1 and ACL2. Okay. So you know that the gain of your difference amplifier, that is difference amplifier, ACL2 is equal to R5 divided by R4, right? So feedback resistor, that is R5 divided by R4. Now you have to find out what is your gain of your ACL1, that is your differential input output amplifier. For that, let me draw the diagram once again. So non-inverting terminal, right? So I am applying V1 VCC minus VEE, and this is your output, right? R1, R2. So this will be acting as your first non-inverting amplifier, and then you have non-inverting with input given as V2, and you have your resistor R3, and inverting terminal will be applied across this node. So this will be your overall output. Let me take this as VO1, output of your first stage. Okay, so let me take the nodes here as A, B and C. Okay, so in order to find out the gain of your amplifiers A1 and A2, here it's VCC minus VE. Okay, so when I apply the voltage V1 across the non-inverting terminal of your amplifier A1, what will be the voltage across your inverting terminal? Due to the virtual ground concept or your virtual short concept, whatever voltage you are applying across your non-inverting terminal, same voltage will appear across the inverting terminal. So same voltage you will be getting across your node B. So node B voltage will be equal to V1. Similarly, same rule applies in the second amplifier also. So your non-inverting terminal, you have your voltage V2, across your inverting terminal also will be your voltage V2. So across your node C, the voltage will be equal to V2. Now what is your voltage across your R2? If I take it as VR2, now what will be your voltage? VR2 will be equal to V1 minus V2, right? Let me take this as VI, differential voltage VI. Okay, now if I assume that the current flowing is I2, now what will be your I2? I2 will be equal to VI divided by R2. Okay, let me take this as equation 1. So what will be your total voltage V01? V01 is equal to, if I take this as VR1 and this as VR3, so what will be your total voltage will be equal to VR1 plus VR2 plus VR3, right? So your total voltage will be equal to VR1 plus VR2 plus VR3. So what is voltage VR1, VR2, VR3 in terms of current and resistors? You have the same current which is flowing, I2. So I can take I2 as common. So what will be your I2 into resistor R1 plus R2 plus R3, right? Now you have already derived what is I2. So substitute the value for I2, which is equal to VI divided by R2 into R1 plus R2 plus R3. Okay, so V0 is equal to VI into R1 plus R2 plus R3 divided by R2. If I bring this VI down, so what is your V0 divided by VI, which is nothing but your closed loop gain ACL. ACL will be equal to R1 plus R2 plus R3 divided by R2. So this, let me take it as your gain of your first stage. So it is ACL1. Normally your value for R1 will be equal to that of your R3. So R1 is equal to R3. Therefore, what will be your ACL1? ACL1 will be equal to R1 and R3 are equal, right? So I can write that 2R1 plus R2 divided by R2. So what will be your total gain? ACL1 is equal to 2R1 plus R2 divided by R2, and ACL2 is equal to R5 divided by R4. So what will be your ACL? ACL will be equal to ACL1 into ACL2. So what will be your ACL1? 2R1 plus R2 divided by R2 into R5 divided by R4. So this will be your total gain of your instrumentation amplifier.